Okay, so I ended the previous video talking about Cepheid variable stars. And Cepheid variable stars are very special because they are very bright, which means it is possible to find Cepheid variables in some nearby galaxies. And a Cepheid variable's rate of pulsation is very directly tied into that star's inherent brightness. So if I measure a Cepheid variable with a period of 30 days, I then could say, okay, 30 days, I know the star's inherent brightness. And if I know how bright the star actually is, I observe how bright the star appears because it's far away. If it's further away, it will be dimmer. I could then turn that knowledge into knowing how distant the star is from me. And if I know how far away that star is, then I essentially know how far away the galaxy that contains that star is. So the Hubble Space Telescope's primary mission was to accurately measure the distance to Cepheid variables. Now, when astronomers first began using telescopes, they noticed there were a whole lot of small diffuse regions of light. These small regions of light, they didn't look like stars. Stars are just points of light on the sky. These were more spread out splotches that were faintly glowing. And so astronomers refer to these diffuse splotches of light as nebula. Now, in modern day astronomy, a nebula is a cloud of material, but at the time, these diffuse splotches looked cloudy, so that's what they were called. So we could naturally ask the question, what is the nature of these nebula? For more than 3,500 years, there have been writings and a written record discussing the nature of the universe. Obviously, what is the nature of the universe around us has been discussed for much longer, but this is what we have recordings from. And if you ever want a really interesting reading, the timeline of cosmological theories is really interesting. And you could go back 2,000, 3,000 years, and some proposals of how the universe works were really, really accurate for the time. Now, we weren't necessarily able to test whether or not that proposal was accurate, but there were a lot of educated guesses some people made that were really spot on. The first recorded observation of another galaxy was made in the year 964 by the Persian astronomer Abd al-Rahman al-Sufi. This astronomer observed the Andromeda Galaxy and the Magellanic Clouds. So these are a couple galaxies that are very close to us. Some really close by galaxies it is possible to see in the night sky using only your eyes. You don't need any telescope or anything to see them. Now, after the invention of the telescope, galaxies still looked like little more than just these diffuse splotches of light on the edge of what you could see. The picture above here's a picture of a galaxy, and this galaxy right here, this is kind of representative of what you would see if you took a 10-inch telescope out on a clear night in Amherst, New York. You're in a suburb, so you're not downtown, but you still have city lights around you. You look at this galaxy. You could sometimes you convince yourself you see it. Other times you might not be sure if you see it or not. But this picture is fairly representative of what you would see. Now, if you take a better telescope with better optics and you take out somewhere where it's really dark, you could attach a camera and your eyes are continuously recording light going into them. But if you let the light going through a camera just collect and collect, this same galaxy over here in much better seeing conditions might look something like this. So at the time, before the invention of the camera, astronomers could look through a telescope. They could see something like this, but not much more. Now, in 1755, the French philosopher Immanuel Kant, I think it was French, proposed that these nebula were actually galaxies separated from our own galaxy. So he referred to these splotches of light as island universes. He imagined that our galaxy is a collection of stars, and these other nebula, as they were called at the time, are other collections of stars, and they are separated from each other. He referred to them as island universes. It turned out he was right, but at the time, this was not it was not known whether or not he was correct in saying this. Then later on, 100 years later, in the 1860s, the astronomer William Huggins applied spectroscopy to some of these nebula. Spectroscopy is the fingerprint of the atom that I talked about a lot in this course. Spectroscopy is such a powerful tool in astronomy. Using spectroscopy, looking at the specific colors of light given off by atoms, he was able to demonstrate that the Orion Nebula is made of mostly gas, mostly hydrogen gas, while the Andromeda Galaxy is made of mostly stars. Now, at the time, astronomers did recognize that a lot of these nebula, as they were called, did seem to possess a spiral shape. And then two very important discoveries for determining what is the nature of these nebula we see in the sky. In 1912, astronomer Henrietta Leavitt discovered that there is a relationship between the Cepheid variable's inherent brightness and the rate at which the Cepheid variable brightens and dims. So if I know, and this is what I talked about a few slides previously. And then in 1923, Edwin Hubble, the guy who had the Hubble Space Telescope named after him, he used this relation between a Cepheid's rate of fluctuation and inherent brightness to measure the distance to some of these spiral nebula. And what he discovered is these spiral nebula are actually very distant collections of stars far, far away from our own galaxy. So Edwin Hubble essentially confirmed Kant's idea of island universes. These spiral nebula are in fact galaxies separate and far away from our own galaxy, other collections of stars. So galaxies are colossal collections of stars, clouds of gas and dust. There are other things in galaxies. There is dark matter, pulsars, black holes. Most large galaxies have a huge black hole at their center. Some galaxies will have 2 or 3 massive black holes at their center. I will talk about black holes and dark matter more, but for now, for today's lecture, I'm mostly focusing on stars and clouds of gas and dust in galaxies. So, broadly speaking, galaxies can be categorized into 4 general categories. They could be spiral, elliptical, irregular, or barred spiral.